Welcome back, everybody. So this is our last formal get-together as we get ready for spring break. So cool. So we're on the week 27, March 31st, April 1st. It's a Wednesday, Thursday. We've been talking about these special right triangles and why we use them so that we don't have to use the Pythagorean theorem over and over and over. The other day we learned some vocabulary, right? The opposite, the adjacent, the hypotenuse, and these shortcuts so that we don't have to do as much math. So let's just recap that because we want to hurry up and get to the fun part of our assignment over spring break. Monty, are you serious? What's your sign? All right, SOH CAH TOA. Part 1. Let's just recap. Mr. Miller is going to hand you this sheet, and we just want to make sure that we don't have to use the Pythagorean theorem over and over and over. Okay? All right. If it's a 45, 45, 90, quick, as a class, 45, 45, 90. We know it started off to be a square. If we know it started off to be a square, we know all the sides have to be 2. Write it. Okay? Now, when we have the leg and we go to the hypotenuse, we multiply. So m is nothing more than 2 times radical 2. Done. We don't want to have to use the Pythagorean theorem. 2 squared plus 2 squared equals m squared. Okay, next one. We have the leg. If one leg is a 5, the other leg is a... Awesome. Write it down. Now, we have a leg. We're going to go to the hypotenuse, multiply. Just 5 radical 2. Good. You guys are getting it now. Okay? Now, if we multiply toward the hypotenuse, remember that, and if you have to, write a note. Across from the 90 is the hypotenuse. Across from the 90 is the hypotenuse. Okay? Across from the 90 is the hypotenuse. Well, now, if we have the hypotenuse and we need to go toward a leg, from the hypotenuse to a leg, we divide out the radical 2. So just write 3 radical 2 divided by radical 2. It would be neat, practice, radical 2 divided by radical 2 is 1. Anything divided by itself is 1. Okay? All right, pause the video if you need to, write your notes down, and away we go. Okay, now the 30, 60, 90 is a little bit more work because we had an equilateral, we cut it in half. When we cut it in half, we have the short leg, long leg, hypotenuse. So I would get in that habit because we're going to have them in all different locations. They're not always going to be nice and perfect like this. So I'm going to just grab a color here. Short leg, long leg, hypotenuse, across from the 90, across from the 90, hypotenuse, short leg, long leg. Okay, and remember the short leg is across from the small angle. Okay, the 30. The 30. So we have the short leg, long leg, across from the 90, the hypotenuse. All right, let's just calculate them. If we know the hypotenuse, boom, always go to the short leg first, boom, divide by 2. 14 over 2 equals 7. Okay, when you go from the short leg to the long leg, short leg to the long leg, multiply by radical 3. Done. 7 radical 3. Okay? Alright, so this guy gives us, ooh, wow, we have the short leg. Well, if we have short leg to the long leg, we multiply by radical 3. Let's just get that out of the way. 5 radical 3. Done. Okay, now from the short leg to the hypotenuse, short leg to the hypotenuse, short leg to the hypotenuse, here we go. Short leg to the hypotenuse, double. just double it. 5 times 2 is 10. Okay? Pause the video. You try the last one. Okay, here we go. Pause the video if you don't have it done. Okay, from the long leg to the short leg. Long leg to the short leg, divide it out. 10 radical 3 divided by radical 3. It's always nice to simplify. Radical 3 divided by radical 3 is 1. Anything divided by itself is 1. So we have a 10. Now we're going to take that 10, because we're going from the short leg to the hypotenuse. Short leg, hypotenuse, double. 10 times 2 equals 20. Okay? So each day we got a little faster because we don't want to have to use the Pythagorean theorem over and over and over and over. All right. So hopefully you got your notes filled out. You've practiced it. Remember, we had our solo activity, okay, where we were to do a couple problems. All right. If you have any questions on those, we'll ask here in a minute. But sometimes in math, we have to solve multiple step problems. So let's take a look at this. All right. Now, first of all, there's two different types of triangles here. Can you locate the 45, 45, 90? And then locate the 30, 60, 90. Okay? Yes. Here's our 45, 45, 90. And here's our 30, 60, 90. Now, in order to get here, we need more information. We're going to need this long leg here. Okay, we got to get to there. Well, we have a 6 and a 6. So what is the hypotenuse of this one? What is the hypotenuse? How do I go from the legs to the hypotenuse in a 45, 45, 90? If you got to look back, okay? From a leg to a hypotenuse, multiply by radical 2. So now I have 6 radical 2. I have the long leg. Now from the long leg to the short leg, you guys remember? Short leg to long leg? Short leg, long leg. No, I went the wrong way. From the long leg to the short leg. From the long leg to the short leg, divide by radical 3. Okay? 6 radical 2 over radical 3. Perfect. Now, we got to go to the hypotenuse. Hypotenuse. From the short leg to the hypotenuse, double. Double. So, 2 times 6 radical 2 over radical 3. 12 radical 2 over radical 3. Okay? Multi-step problems. Multi-step. Do them a piece at a time. And if you would have had to, go ahead and break them apart so that it's easier to see them. Okay? There's nothing wrong with that. All right? Now, off to the side, we don't like this. We like to get rid of that. So I'm going to multiply by the top and the bottom, radical 3 over radical 3. This is called to rationalize. Okay? You don't have to do this, but in math, there's kind of an understood rule. We don't like square roots in the basement. So a better answer here is 6 radical 6 over radical 9. And we know that the radical 9, the square root of 9, is 3. 6 radical 6 over 3. And we can simplify this. Don't do that. We can simplify this to a 2. So the best answer is 2 radical 6 Now we come down here, 12 radical 2, radical 3, multiply top and bottom by radical 3 over radical 3, which is just another name for 1, giving us 12 radical 6 over radical 9. We know the square root of 9 is 3, giving us 12 radical 6 over 3. And we know that 12 divided by 3 is 4, giving us 4 square root 6. Isn't that double? Alright, pause the video, kind of follow that train of thought. We don't have any long problems like this, but it's fun to push ourselves mathematically, alright? There was one more problem here before we move on. And it's always helpful to draw a picture first. So let me read it. Jeremy is going off to show his skateboarding ability to his geometry class. He has a skateboard ramp that must be set up to rise from the ground 30 degrees. If the height from the ground to the platform the ramp sits on is 8 feet, how long is the ramp? Okay, so now pause the video, draw. Pause the video and you draw. Alright, this is what I'm visualizing. Ground, ramp, and the reason it's important is because your answer is dependent on what you visualize. You might read it totally different. Your drawing might be totally different than what Mr. Miller and I come up with. This is what we think. Okay? So we'll grade you based on your work. But this is what I see. Okay? The 8 is this distance right here. Okay? And it's a ramp, so we have a 90 degree, which makes this a 30, 60, 90. So in our world, we have a 30, an 8, a 90, which means this is the long leg, short leg, hypotenuse. So that's going to be our answer. Now pause the video and get your answer before you watch our math. Alright, welcome back. Now, if you remember on our cheat sheet, to go from the long leg to the short leg, we divide. So we have 8 over radical 3. We divide out. Then, to go to the hypotenuse, we double. So 2 times 8 over radical 3. Okay? Which gives us 16 over radical 3. Alright? So that's how we visualized it. That's how we did the math. Now real quick, because in time we're going to want you to know how to rationalize. We want to get rid of the radical 3 in the basement, giving us 16 radical 3 over radical 9, which this is just a 3. So a better answer is 16 radical 3 over 3. Alright, now to finish this week as we go to spring break, we want to introduce you to SOH CAH TOA. What is this SOH CAH TOA we've been talking about that's on the back wall? The sine, the cosine, and the tangent. It's called trigonometry. Okay? And to introduce this subject, we have a couple of links here. Okay? So in class, Mr. Miller is going to click on this. Mr. Miller will click on this link right here. Boom. And he's going to show you that mathopenreference.com, outstanding website for math. Okay? All things geometry. We want you to visualize that all the sides of the angles of a triangle are just a relationship. As one side gets bigger, the angle gets bigger. So as the angle gets bigger, this side gets bigger. But if this stayed 90 degrees, then as this one got bigger, this one gets bigger. What are you talking about, Monty? So we'll click on this link, and it's going to take us to Math Open Reference. Now watch angle C down here. As I make C smaller, you see how the side opposite got smaller? As C gets bigger, do you see how the side opposite got bigger? Likewise, the same thing here. Okay? It's a relationship. As the angle gets bigger, the side gets bigger. As the angle gets bigger, the side gets bigger. They're proportions. And we can describe that mathematically. It's awesome. Now, in Math Open Reference, you can find all the SOH CAH TOA stuff. I personally like mathisfun.com. So write that one down in your notes. Click on this link. Poof. And it takes us to Math is Fun. Now, why do we spend so much time talking about trigonometry? Mathematics is the describing of the world with numbers. And there's lots of things in the world that go up and down. When you ride a Ferris wheel, tides go in and out, your heartbeat. We need to be able to describe that mathematically, and that's done with trigonometry. This idea of sine, cosine, and the tangent. And their relationships. As the opposite gets bigger, so does this angle. As the adjacent gets smaller, so does that angle. So we need to be able to see it, understand it, and then talk about it. In time, remember the unit circle Mr. Miller handed you that day? We describe circular motion via triangles, trigonometry. So as I move, you see how the sine, the cosine, and the tangent all change proportionately. They're all similar. All right? And then real quick, circular motion described in the XY plane looks like this. As I go around, we can model the behavior. Okay? All right. Now the fun part. Your homework for spring break. Okay? We need a way to memorize SOH CAH TOA. Serious. We need a way to memorize it. And when I was your age, we had sayings, we had rhymes, we had riddles, we had a mnemonic. Have you ever used a mnemonic in another class? Right? PEMDAS, my dear Aunt Sally. What does the O stand for? What does the H stand for? The A stand for? The H stand for? The O stand for? And the A stand for? Your assignment is to create your saying or song over spring break. But before we go today, here's some actual examples of songs. Okay, so this first one is a rap. You guys like rap? Okay, click there, and here we go.
Jason Let's look at this right triangle problem. With trigonometry, now we can solve it. Notice that you're only given one side, but you got a couple angles on the inside. SOH CAH TOA. Identify your opposite and a
All right, there was the first one. Now, different way, different idea, different rhythm. You might recognize the parent song on this one. Click it, and here we go.
Excuse me, math teachers? Got the results of the recent math assessment. Did really well. Really well. Really proud of you guys. Did have a question though. Noticed some issues with right triangles. Wondering if you can put your heads together and maybe come up with some new ways of teaching things about trigonometry.
All right. What kind of trig functions? What can we do? Yeah, right. That's what you're gonna do.
track once again. Here the mixture trig is a topic you understand. Right triangles are the key to the task at hand. Here are my friends to help you comprehend. Sine is opposite over hypotenuse. It's a ratio of the sides. Cosine's adjacent over hypotenuse. It's a ratio of the sides. Tangent opposite over adjacent. It's also a ratio of the sides. SOH CAH TOA style. 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 Hey, right triangle.
You guys recognize that song? All right, let's try a different one. Now, just a different way, trying to memorize SOH CAH TOA. What does the O and the H stand for? Come up with a saying or a song over spring break. Try this one.
Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent. Long sides of hypotenuse, and the other two sides depend on which angle you're focusing on. Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent.
All right, and then the last one for this video, and this is my favorite, but I happen to be like, I like this song. Okay, so I'll just click the link, and here we go. I bet you recognize this one.
Because we are finally going to start our unit on trigonometry this morning. Miles.
Is there any way we can make this more fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. Just can't sit. Gotta get tricky with it. All that's it. 3 angles, 3 sides. T-R-I-G, all up in my eye. SOH CAH TOA will tell you where to go. You just gotta know about H and O. Everybody looking at SOH CAH TOA helps you study so you know when to use it.
All right, so that's your challenge over spring break. What is this thing called? SOH CAH TOA. What's this thing? Trigonometry. And figure out a way so that you can remember OH, AH, OA. Have a great spring break, everybody. It's been fun. It's going to warm up. See you in April.